Alright guys, let's take a look here at these. This first one is just kind of screaming at you what to do because it's just loaded with all the same kind of stuff. So what kind of problem is this? What do you always try first anyway? But yeah, GCF. You always try greatest common factor first. And this is just screaming at you that it's probably all this is. Are there any like terms?
Yeah.
Which ones?
5 and y.
Are there no. Are there like terms? Are there like terms? No, there are no like terms. So don't try to combine these and say, I don't have to factor anything because I combine them all. There's no like terms up there. Now come at me with, what's the GCF? 5. M. Y. Good. Because the lowest power on each is 1. He can only give 1 Y, he can only give 1 M. So no matter what the other ones can give, you just take what the least can give. Right? It sounds almost nice, but not quite. Take everything that the least has. Alright. 5's gone. I had 2 M's, I took 1. I had a Y, I took it. Minus 3. Good, because the M's gone. I had 3 Y's, I took 1. Good, 20 divided by 5 is 4. Yeah, I had 2 of each, and I took 1 of each, so I have 1 of each left. Oh, my. Okay. Cool. And then, now the inside, this is a trinomial, but does it look like it's going to be factorable like number 3 is? Does it look like it's in the same format? No. No, totally not. Okay. So that's it. That's all you do. Bam. And then what about this guy? Well, how many terms are there here? 4 terms. Is there any GCF across on everything? Hell no. He's got no X. He's got no Y. He's got no numbers. They ain't got no chance. But I take 2 of them, right? And this is the what method? Grouping method. It's crazy because math people were so creative.
I will group them. We'll call it grouping method.
And then, so what comes out of the first group? 4. Y, I like it. That poor little X dude is left alone. 12 divided by 4 is 3. Took the Y, I like it. So you know you want X plus 3 to show up over here. So then what do you have to take out of both? If I just take an AX out, then there'll be negative stuff left in, but I don't want it to be negative. And then take a negative AX out. Guess yeah? Because I know I want the answer here to be positive, so I have to take a negative out of them so they become positive. There's no guessing. So what's left then in this dude? Good. Took the A, took 1x, so there's an x left. Took the negative. Took the negative here. And took the AX. Took the x. And how do I know things look like they're in the right track? Yeah, because these two guys are the same, so since they're the same, I'm allowed to do what with them? Same way we did with the y here, we took it out. We can take x plus 3 out. So what I really want you to understand is, sometimes people put like a squared here or something because they say there's 2 of them, and I say, you're crazy, there's not 2 x plus 3s. There just ain't. And again, this is a place where people worry about my mental health. But there's 1 x plus 3 that was distributed to this guy and this guy. There's one of them that was distributed to 4y and minus ax. Bam, bam. I like it. Okay. Alright, what about, this is the newer one we just did last time, number 3. What is it that I'm looking for on number 3? I hear something. Yes?
It's what multiplies to get the first and last term. but adds to get the middle term.
I like it. So you can start thinking about factors of 16 like 4 and 4, but they add to be 8. So they're no good. 16 and 1, they add to be 17. They're no good, right? So it's not 4 and 4. It's not 16 and 1. Yeah, it's 8 and 2. I like it. 8 and 2 make 16 when you multiply, and 8 and 2 make 10 when you add. It is a little number game, right? And I know number game does not sound like excessive amounts of fun. Sounds like a car trip. Let's play a number game. No, it's not. But what's definitely going to go in the first place to make x squared? X and x. So when the first number is a 1, the whole thing is about figuring out the numbers that work. And the only numbers that work, they have to make this when they multiply, and they have to make this when they add, just because of the way that we FOIL. We looked at some examples and we realized there was a pattern there. So then we used the pattern to make a process. That's a huge part of math. So we get x and x to make x squared. 8 and 2 multiplied by 16, and they both, of course, have to be positive to make positive 10. So notice if that would have been a negative, they would have just been both negative. That would have been the only difference. Okay, cool. Now real quick, let me do my weirdness. Right, green, so you guys know this is weirdness. If x were, I don't know, 2. If x is 2. And why did I make x 2? Because I wanted to net. I can make x whatever the hell I want to. Because what can x be? Anything. I can make it the square root of 11. I don't want to do that. So if x were 2, what number is this? This is just a number that I don't know yet, but now I know it. What number will this be? This is 4 plus 20 plus 16, and what's that? 40. And if x is 2, what's this? 10. Is that a way to factor that? Yes. So again, I can't stress this enough. That's a nice little way to check your work if you have time. But that verifies the crazy statement I made before. When you do this to this, you have factored an infinite number of numbers. That's a pretty good amount of work. Because you can make x anything you want it to be. Anything you want it to be. Real quick, what would I make x so that this comes out to be 0? Don't try, if you look at this, it'll take you forever. Isn't this the same thing? These are the same thing. So what would I make x to make this thing 0? What would make x to make this 0? Negative 2. Do you guys see that? Negative 2 would make this 0, right? But it makes this 6. Who cares? 0 times 6 is 0. Do you guys see what I'm saying? Somehow this is important, what I'm saying right now. So how do I make this 0? I can make it negative 2. X is negative 2, or x is negative 8. So if x were negative 2, let's try this out. We know that this is 0. 0 times 6 is 0. Is everybody with me? If x is negative 2, that is definitely 0. Times, who gives a shit, is 0. But let's check it out. If x is negative 2, what's this here? 4. 10 times negative 2? And sure enough, 4 minus 20 plus 16 is freaking 0. I like it. That somehow has something to do with a section coming up in our very near future. Okay, I like it. That was nice and cryptic, Jeff, I know. Alright, so same idea here, right? The first number is a 1. So I know it's going to be x times x to make 1x squared. That part's done for me already. I just got to figure out the numbers that make it work. And what numbers multiply to be negative 40 add to be negative 2?
6 and 8.
Yeah, it's going to be 6 and 8. Which one's got to be negative?
8.
The bigger one. Kick ass. Why were they allowed to be different signs here? And these were not allowed to be different signs. Why? Because how do I make multiply to be positive 16? They have to be the same sign to do that, don't they? How do I multiply to be negative 48? They have to be different signs to multiply to be negative. Does that make sense? I mean, these are all little things that you consider. Don't look at them as like a bunch of things to memorize. Look at them as a bunch of things trying to help you, point you in the right direction. How we doing? I see quizzical looks but no questions. Okay, yes?
Is there an like imaginary Wi-Fi number for when you distribute, like, I don't know how to explain.
Well, there is a 1 like right there.
That one, you factor it out to x plus 6, or?
No. Okay, all right. I looked at this entire thing to figure out that number, to be honest. Right? Because I know that this times this makes the last number, so they got to multiply to negative 48.
I got that.
And I know that this plus this has to make the middle number. So the fact that the first number is 1 is what makes this problem that easy. If the first number was like 8, couldn't this be 8x and x? Wouldn't that make 8x squared? What about 4x and 2x? What about 2x and 4x? What about 1x and 8x? And oh shit. So when the first number is not a 1, which we're going to get into today, it's a little bit more complicated. But yeah, since that first number is a 1, I can focus all my attention on these two numbers because the only way to make x squared is x times x. Really. I like it. Let me show you, let me show you this here. It's not up to us here, let me just show us whatever. Okay. What if I had this here? You like it already? I like it. Now, really analyze, why did I put x in x? Because x times x is x squared. Now, notice how the middle term has a 1 on. Why is that good? Because 8x plus 2x is 10x. So if I extend the idea, the middle power has to be half of the first power. Because what do we do with the first power? We cut it in half. So will this work? Is the middle power half the first one? Yes. And x to the 6th, how would I break that up? Yeah, x3, right? X cubed. So the powers almost don't matter as long as this one is half of this one. And then the process is exactly the same. I cut that in half, and then what numbers are going to work? What two numbers multiply by negative 26 and add to be negative 11?
2 and 15.
Yeah, it'll be 13 and 2. I like it. Which one's going to be negative?
15.
The bigger one. I like it. So I could have put a 10 there, as long as this would have been what? If I put a 10, this one better be a 5. That's crazy. Right? So that power doesn't, as long as it follows that, your whole purpose is the same, finding those two numbers that work. Crazy. It's crazy. Okay. So, I think I want to do, I got a whole other little thing. I kind of like this setup. I don't know if you guys agree or not, but the whole little motivation thing and all that kind of stuff. This is the way I normally teach it. I want to do the first one with you, and then I'm going to unleash you on the rest of this. So, we're now going to get into, what if this thing is not a 1? What if that's not a 1? Oh shit. So like I said, things get a little more complicated. The process is going to be just a little bit longer, and that should make sense because there's so many possibilities. So I don't like going down the road of, well, just try every possibility until you find the one that works. That's a little insane. Some of you guys might be able to do that. The more you can play with numbers really well, the quicker you can zero in on what's going to work. But I'm going to show you the process that will always work. In fact, when it was taught to me, my teacher called it the surefire method. I was born in Georgia, but we moved away when I was 5. So I didn't take factoring when I was in Georgia, but it sounds like a Georgia thing. Surefire method. I like it. I'm a Southern boy. I can say that. So where would something come from that does not have a 1 out front? Well, it can't come from x plus something. It's got to come from something like, let me do this one specifically. So that's definitely not going to have a 1 in front, right? Go ahead and multiply that out for me. Oh boy, my southern roots are coming through now. I'm thinking about Georgia. I know, doing like a multiplication like this should be like, you should be begging me, Jeff, give me a bunch of those. So that's just so easy. I have no problem saying that normally evil 4-letter word to say in a math class, easy. This has desperately got to be easy. This is multiplying and adding. That's always easy. Factoring is the reverse of that. That's going to be more difficult, not impossible. So of course, how do I do this? I get bless you. All right, I like it. So I get 6x squared plus 29x plus 35. Now let's check a couple things out. Does our old pattern hold? 35 is 5 times 7, the same way that negative 26 is negative 13 times 2. Do you guys see what I'm checking here? So the numbers multiply to be the last number. What else were they supposed to do here? They were supposed to add to be this guy. Does that still happen? What's 5 plus 7? Shit. Now, of course, why didn't that work? Why didn't they add to be 12? Why isn't this 12? Because those stupid numbers get all mixed up in this stuff, right? Do you guys see that? So that's not 5. That's not 5. That's now 15 because that stupid 3 messed with it. That's not 7. That's now 14. That stupid 2 messed with it, right? Do you guys see what I'm saying? But here's a really, really weird kind of thing. But on the other level, it's kind of not really weird at all. But let's see if you guys get this. Help me out. Somebody help me out. What is let's see which way I went. What is 14 times 15? 14 times 15. 210. What is 6 times 35? Okay, that's interesting. And you're all like, okay. But you should be. Now, on one level, it's not a big, huge surprise because these numbers have these numbers in them. There's going to be possibly something like this happening. The neat thing is that always happens. And we build our process off of this fact. 6 times 35 is 210. I then find factors of 210 that add to be 29. You see that? 14 and 15, and they add to be 29. And they multiply to be the same thing that these do. So it's the same thing we did before. What's 1 times 26? 26 is amazing. And then I find factors of negative, well, it's negative 26, and then blah, 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 blah. So when there's a 1 out front, that kicks ass. It doesn't mess anything up. It's very straightforward. There's no things to worry about. When there's not a 1 out front, oh shit. I've got to take it into account. So let me see how far you guys look appropriately excited. Let me see how far you guys can get with this. Group up if you want to. Little tiny groups today since we have so many people elsewhere. Maybe they all moved to Canada, I don't know.
You know the website crashed for the Canadian citizenship that night?
Yeah. And some Canadian was joking. They said, yeah, we did that on purpose. We don't want you guys coming up here. You're crazy.